Here we're going to take a look at some ideal gas laws and combined gas law problems. Okay, let's look at our first question. Sample of a gas occupies 650 milliliters at STP. What volume will the sample occupy at 100 degrees Celsius and 5 atmosphere? Okay, this problem here is a classical combined gas law problem. First, we need to know what the formula looks like, which is P1V1 over T1 is equal to P2V2 over T2. Alright, we're told that we have a sample gas occupies 650 milliliters at STP. So our V1 is equal to 650 milliliters. Our P1, which is equal to 1 atmosphere, and our T1, which is equal to 273 Kelvin. STP stands for standard temperature and pressure. Standard temperature is 273 Kelvin and standard pressure is 1 atmosphere. We're told in the problem that what volume, so we're asked to find volume 2, that's our question mark, this is our V1, will occupy a sample at 100 degrees Celsius, so that's T2. So it's going to be 100 degrees Celsius plus 273, which is going to give us 373 Kelvin. And then our P2 is going to be equal to 5.00 atmospheres. So the question that we need to be able to do is take this equation and solve it for V2. So we need to have V2 by itself. So we bring this here up, T2, bring this one here down, P2, and we'll have our formula that V2 is going to be equal to P1 over V1 over T1 times T2 over P2. So this is the formula that we would use to solve for the volume. So it's just a matter of rearranging the equation. So we have V2 is equal to P1 times V1 over T2 divided by T1 times P2. We already know what our units are. Volume 1 is 650 milliliters. P1 is equal to 1 atmosphere. T1 is equal to 273 Kelvin. V2 is what we're looking for. We're told that P2 is equal to 5.0 atmospheres and that our T1 or T2 is equal to 373 Kelvin. When we substitute these things back into the equation, we're going to get 1 times 650 times 373 over 273 for T1, and for P2 we have 5 atmospheres times 5. When we do the calculations, our final answer would be 178 milliliters. Okay, let's look at another problem. It says the volume of a sample of gas